In this video, we're going to be going over a reaction type called precipitation. For this, you are going to need your notebook, you're going to need something to write with, and for this, it would help tremendously if you knew what your solubility rules were. So if you're kind of a little bit shaky on them, what I would do is I'd go take some time to learn those a little bit and then come back and watch the video. But once you have all that stuff ready, let's go. Okay, so I promised this in the last video, but I have it here instead. So we're going to concentrate our reactions that you learned in sophomore year down into 3 new reaction types. So sophomore year, you learned your basic 5 reactions: synthesis, decomposition, single replacement, double replacement, combustion, right? In a synthesis reaction, you have 2 things and they combine together to form one large substance. Decomposition is the opposite. So you have your one large thing and it breaks up into smaller things. Single replacement, you have an element and you have a compound. And what happens is the element switches out for one of the elements in the compound. Metal replaces metal, non-metal replaces non-metal, right? So in this case, A and B are both metals. So I'm going to have B plus AX. Double replacement, you have 2 compounds, so AX and BY. And all that happens is the 2 positives, so A and B, will switch places. So A will wind up with Y, B will wind up with X. And combustion is just a hydrocarbon, right? So C something, H something, plus oxygen will form water and carbon dioxide. So those were the 5 types you learned in 10th grade. And for the most part, these 5 types are still good. Like, you can still use them regularly and they'll still help you get the correct answer. All we're going to do is we're going to concentrate these down into 3 smaller types. Right? So our first type is precipitation. Precipitation, I'll go over in the next slide, is when you produce a solid from a reaction. Precipitation reactions are always double replacement. The second reaction type is called acid-base. This is usually double precipitation, although sometimes you will see a little bit of precipitation in here, and occasionally you may see a single replacement variant on this, but that's actually quite rare. The last type, and this is going to be the largest type, this will cover synthesis, decomposition, single replacement, and combustion. This reaction type is called redox, or oxidation reduction. If you remember sophomore year, some of you learned how to balance redox equations, especially in acidic and basic solutions, and how much of a pain in the neck that is. Well, guess what? It's back. Right, so over the course of the next 3 videos, we're going to be going through these different reaction types. Or actually, I should say 4, because I have 2 videos on redox. All right, this video, we're going to start off with precipitation. It's the easiest of the ones to learn, so we're going to start off with that one first. Again, a precipitation reaction is any reaction that produces a precipitate, which is a solid product. Right, so in our previous example, on the previous video, we produced magnesium carbonate solid. That was our precipitate, so the reaction was a precipitation reaction. Always double replacement for precipitation, so we'll always follow that pattern if you want to make it easy to work with. And the key thing here to know your precipitation reactions is you have to understand your solubility rules, right? So you have to have them memorized. The reason why is because you need to know what compounds are soluble and what compounds are not. That way you can write the correct net ionic equation for this precipitation reaction. And one thing I will point out that you should be aware of is occasionally you'll get a reaction where both products are precipitates. So you have the very rare what's called double precipitation reaction. So just keep that in mind as a thing that can happen. It's not always just one precipitate. All right, so we'll start off with an example. So for our example, we have silver nitrate and barium chloride, and we're going to mix those 2 solutions together. Now we know our ions, right? Silver ion is Ag. Its charge is +1. Nitrate is NO3. That charge is -1, so AgNO3. We're reacting that with barium chloride. So barium is Ba with a +2 charge. Chloride is Cl with a -1, so BaCl2. This is double replacement, so what's going to happen here? Right? The silver and the barium are going to switch places. Now, just to finish out the reactions, just so we can get something down here and balance it, here's our completed reaction. Now, you notice we're missing something here. We're missing states of matter. The reason why is because I'm going to show you kind of the shortcut way to do this. If you want to go through and do states of matter and then do complete ionic and net ionic from that, by all means, please do. It'll just take you a little bit longer. But here's the shortcut way. This is why you need to know your solubility rules. What we're going to do is we're going to look at the different combinations of ions and see what can precipitate. Right? So silver nitrate. Nitrate's always soluble. That means silver nitrate is AQ. Barium chloride. Halides are usually soluble. The exception are heavy metals. Barium is not a heavy metal, so this is AQ. Silver chloride. Halides are usually soluble, except for heavy metals. Silver is a heavy metal, so silver chloride is a solid here. And then barium nitrate. Nitrates are always soluble no matter what, so this is AQ. So among these substances, the only solid we're forming is silver chloride. So if the only thing we're forming is silver chloride, I'm just going to write the reaction that forms that solid. Right? So the reaction that forms that solid are silver ions plus chloride ions makes silver chloride. Now, if I were to do this from a complete ionic, I get 2 silvers, 2 chlorides, 2 AgCls, right? So 2, 2, and 2. We reduce that to lowest ratio. We get 1, 1, and 1. So here is our net ionic equation for this precipitation reaction. Ag plus Cl minus yields AgCl solid. Right? So if you know your solubility rules, this process, once you see a question like this, you can have it done in 30 seconds. If you want to go through and do complete ionic, net ionic from that, feel free to. Just keep in mind that it will take you slightly longer to do, so you're going to need to work on saving time in other places. All right, so that's precipitation. You're just forming your solid product. In the next video, we're going to cover acid-base reactions. It'll be a little bit of a longer video because I also have to review the concept of acids and bases with you. And then the 2 videos after that, we're going to be doing redox.